There we go. Alrighty. So yesterday we started with factoring. So we had that P.5b and we had a handful of problems to work on. You guys got any questions on any of those? Which one? 16? I can do 16. Alright, so 16, we have x to the third minus x squared minus 5x plus 5, right? So these ones, they want us to factor by grouping. So to do groups of 4 terms, we're going to do 2 and 2. A lot of times when I go to figure out how to set up my groups, I look at that constant term, that 5. He's usually the one that kind of determines who we can pair with, because we can't pair with the x squared and we can't pair with the x to the third. The only guy we can pair with is the 5x, right? So I'm going to pair these two together, and then I'm going to pair these two together. So on that first pair, x to the third minus x squared, pulling out that greatest common factor, I'm going to pull out x squared. So to get back to x to the third, I got to multiply by x. And then to get my x squared, I got to multiply by -1. Right? Everybody good with that group? So on the second group, we got to make a decision. We either have to factor out -5 or a +5. You want to do a +5? So if we factor out a +5, to get to -5x, we'd have to multiply by a -x, right? And then to get to our +5, it would be +1. So our goal when it comes to factoring by grouping is we want to be able to keep going with those factors, right, and factor something else out. So the way it's written right now, that x minus 1 and -x plus 1, those babies don't match up, so we can't factor it out. So if I look at this guy, I can technically factor out a -1 out of here, right? So if I factor out the -1, I'm just going to put it with the 5, so I'm going to have a -5. And then that would give me x minus 1. And if I just bring down my original part of my group, now these two match up. Now I can factor it out. So if you go through and you're working on these and you get to where these two don't match, and a lot of times it has to do with always having that negative somewhere in the problem, either go ahead and factor that negative out, or just kind of go back to the original problem, and instead of factoring out that +5, factor out a -5 to see if that gets it to where these factors are the same. So now we can factor out the common factor of x minus 1, and then that's going to leave us with x squared minus 5. And now we're down to 2 factors. Does that help? Awesome. You guys got any other ones? Which one? 14? So it's probably, is it close to kind of like how this one gets us all? I think we can put it over here. I think we got room. So we have x to the third plus 6x squared minus 2x minus 12. So this one, if I look at my 12, I technically can pair it here and I can pair it here. So everybody can kind of pair with everybody else, except for just the first and the fourth are the only ones you can't pair up. So any personal preference? First two, last two? 1, 3, 2, 4? Yeah. sometimes simplicity works better, right? So let's do those ones. So x to the third plus 6x squared, greatest common factor I can pull out is x squared. Yep. And that's going to leave me with what? X plus 6. So now I have my -2 and my -12. So do we want to pull out a +2 or a -2? I'd pull out a -2. Right. So -2 times what's going to get me to -2x? X. And now I got -2, so what am I going to multiply -2 by to get to -12? +6, right? +6. And that's where sometimes our little boo-boos and mistakes come in, is on that step right there. We always, when we pull these negatives out, and we're trying to multiply to get that factor, we see this -12 and we want to throw that in as a -6. But we got to make sure we're looking at this guy, right? Because this is what you're multiplying by, and there's that negative out there in front. So -2 times a +6 is going to get me -6, right? And then x squared minus 2 and x plus 6. And if I looked at this quadratic, it's not a perfect square, so I can't factor it any farther, so I'm good to go. All right. Ready to add a little spice onto our factoring problems? Woohoo! All right. So finishing up with P5, so now we're on to what? P5b. And we're still factoring polynomials. And today we're going to focus on one type of polynomial. We're going to focus on trinomials. So if I have a trinomial, how many terms do I have? 3. Yep. So in years past in your mathematical career, a lot of times when we're looking at trinomials, we're looking at quadratics. That ax squared plus bx plus c, like in that standard form. So we're going to be factoring some quadratics for the most part. And there's a couple different ways that we know how to factor trinomials. We can do the X box method, or they call it the area model. We can use what's called FOIL, which is kind of like using the X, but you're kind of doing it more mentally than writing everything out. And we can also do it by grouping. So we're going to kind of go through just the different options. And again, like in math, it's kind of like where you feel comfortable at. It's like it's nice knowing the different methods, but when it comes to factoring, it kind of becomes a little bit of a personal preference on like where you want to go. Like for me, a lot of times I usually try to do like the FOIL method just because it takes less paper. But if I'm kind of struggling with trying to figure out what numbers go into that FOIL, then maybe I'll do the X box, or even factoring, or the by grouping. I like doing it by grouping, but that's just personal preference, right? So we're just going to kind of run through a couple different options, right? So we're going to start off with a easy little trinomial, and then we're just going to kind of keep adding a little bit of spice onto it until it gets too hot we can't take it no more. All right. Start off with maybe a bell pepper, and then maybe move on to like a banana pepper, then on to I don't know what's hotter, jalapeno or chili, I don't know. Maybe get into some habaneros at the end. Okay. I'm here all week. Alright, so let's say we have x squared plus 3x minus 18. Squeeze it up a little bit for you guys. So we got a cute little trinomial, and we want to figure out the factors. So we want to figure out what two things can we multiply together in order to get that quadratic or that trinomial. So usually when you first start getting introduced into these quadratics, your teacher started you off with the little x, and so they drew this little x for you. And they said on top we do a times c, and on the bottom we do b. So when we look at our trinomial, we need to figure out our a, b, and c. So our quadratic is in that nice little standard form. So we need to figure out our a, b, and c. So our a is in front of the x squared, and what's in front of our x squared? 1. Yep, so a is going to equal 1. Our b is always in front of our x term, so our b is going to be 3. Yep. And our c is our constant term, which is negative 18. Okay. So in our x, we got to figure out a times c. So a times c is going to give us negative 18. And our b is going to be 3. So now we need to figure out the left and the right side of our x. Oop. So ultimately, we need to find values that when we multiply, we get negative 18. So I always start just with the sign, because I have to multiply in order to get a negative. So my numbers either have to be positive and positive, negative and negative, or one's got to be positive and the other one's got to be negative. So what option do I have in order to get a negative number? One's got to be positive and one's got to be negative, right? Thank you. So now I'm going to look at my 18, and I'm going to list all the different factors in order to get 18. So I could do what? 1 times 18, 2 times 9, and 3 times 6. Right? So now when I multiply my factors together, I have to get 18. But when I add the two numbers together, I put the numbers together, I have to get 3. So out of these little combinations, if one's positive and one's negative, which one's going to get me to 3?
Positive 6, negative 3.
Yep, good job. 3 and 6. Yep. And because this is positive, I know that my positive number's got to be the 6, and my negative is going to be the 3. So ultimately what we're really doing, so since our a is 1, we don't have to use the box method because there's nothing out front to factor out, because out front is already a 1. So this is giving us our factors. So this is telling us we have, so then those are going to give us our factors. Whoop. So we have x plus 6 and x minus 3 is our factors. Let's try, let's say we had x squared minus 5x minus 14. So when it comes to the FOIL method is really similar to doing this whole x, except you're not really writing out the x. You're just kind of doing it all in your head. Because we have a quadratic, we know that we're going to be down to 2 factors. So factors are things that we multiply together. So we're just going to set up our parentheses. And then to figure out what variable we got going on, we know that we're multiplying, and we got to multiply to get x squared. So what can we multiply together to get x squared? And x. Yep, good job. So just like when we did the box, you're really just going through that whole process, but you're just going to kind of do it in your head more mentally. A times c is negative 14, right? So we got to get a negative number. To get a negative number, I know that my signs have to be positive and negative, right? So I'm multiplying to get negative 14, or just 14, so that's 1 and 14 and 2 and 7. I know that my signs are going to be the opposite, so I'm going to subtract them. And I have to get a difference of 5. So 1 and 14 is only going to give me a difference of 13. 7 and 2 is going to get me to 5. So now I just have to figure out which one's going to be positive and which one's going to be negative. Yeah, it's going to be negative 7. Because I have to get to negative 5. So this would be the negative 7, and this would be a positive 2. And then I just always do a quick check. When I multiply these two together, what do I get? Negative 14. Yep. When I add these two together, what do I get? Negative 5. So after you get to that point, you can just kind of do like a quick little double check. Multiply them together, see if you get the last term, add them together, and see if you get that middle coefficient. Not too shabby. So what we try to do somewhat in mathematics is, it's like like when we're first getting introduced into trinomials and having that whole visual representation of that x. But it is nice because it kind of helps you work a little bit more efficiently if we can kind of get to where we can factor without making the whole x. But if you still make the x, you still make the x, right? All right. So these are all fine and dandy when our coefficient in front of, or our a is 1, or our coefficient in front of x squared is 1. But sometimes in math we like to get a little bit more fancy and actually put numbers out front. So what if we had a nice little trinomial let's go with 8x squared minus 10x minus 3. So the first thing I'm always going to ask myself, is there a greatest common factor that I can factor out of this before I do anything? So I'm looking at 8, 10, and 3. There's nothing I can factor out of there. And then on my variables, I don't even have a variable in that last term, so I can't do that. So sometimes they'll try and trick you up a little bit, and they'll make it to where like you could pull a 2 out of everything first. So make sure you're always checking to see if there's that greatest common factor you can pull out to begin with. All right, so we're going to go through 2 different methods on this one. We'll do one using the X box, and the second one we'll do by grouping. Sound good? All right. So when it comes to the X box, we got our little x. Okay. A times c is on top and b is on the bottom. And then on our problem, a equals 8, b equals negative 10, and c equals negative 3. So a times c is going to give us, yeah, b is going to be negative 10. So I got to multiply to get a negative. So I know one of them's going to be positive and the other one's going to be negative. So I got to multiply to get 24, and it's going to give me a difference of 10. Anybody got any ideas? Now what do we got? Positive 2 and a negative 12. Yep. Everybody good with those numbers? Alright. So because our A is 8 and it's not a 1, we still have to play around with that guy, and we actually have to factor him into the whole problem. So this is when our box comes into play. So right now we have a trinomial. Uh-oh. Yep. But these little guys are actually telling us what this middle term is. And instead of writing it as negative 10x, we can just rewrite it as a positive 2x and a negative 12x. Right? So when I go to make my box, how many pieces are in the inside? There's 4 pieces on the inside. And if I just look at my original trinomial, how many factors do I have? 3. So I have a hard time taking these 3 and putting them into 4 spots. So that's what the box or the x does, is it breaks up that 10. So I now can rewrite this quadratic as 8x squared plus 2x minus 12x minus 3. And are those values the same thing? They're exactly the same, right? You're just writing it in a different representation. Instead of writing it as negative 10x, you're just writing it as 2x and negative 12x. So now I have 4 terms. Can I fit 4 terms into 4 spots? Yeah. So now we're just going to put those into our little box. So 8x squared, 2x, negative 12x, and negative 3. Not too bad. Alright. So now we got to go around our box and we got to pull out those greatest common factors. So I'm just going to start with these two. So if I just look at my numbers, 8 and negative 12, what's the greatest common factor I can pull out of there? 4. And between x and x squared, I can factor out x. Yep. And then I'm just going to move over to these guys. So 2x minus 3, what's the greatest common factor I can pull out of there? 1. Yep. And a positive 1. Whoop. So I just even write positive 1. Now I'm going to look at these two. What's the greatest common factor between those guys? 2x. Yep. And I'm going to do the same thing on the bottom. What can I pull out of negative 12x and negative 3? Negative 3. And then now these guys, guess what those are? Those are your 2 factors. So if we do 4x plus 1 and we multiply that factor by 2x minus 3, we could get back to our original quadratic. And I know we started doing these last year in Algebra 2. I don't know how much, we didn't get into them a whole lot, but we were at least starting some of them, weren't we? Alright, let's do one more where our A is greater than 1, and then we'll kind of do it by grouping, which is like what you guys did yesterday. So let's start with 6x squared plus 19x minus 7. So I'm going to look at my problem and I'm going to go, is there a greatest common factor I can pull out of everything before I even start? No. Okay. So I want to be able to write these 3 terms into those 4 terms. So again, if you need to, you can kind of write your little x out. What's going to go on top? Negative 42. What's going on the bottom? 19. What's going on the left and right? Yep, good job. So 21 times negative 2. So if we were to rewrite this as 4 terms instead of 3 terms, we would have what? 6x squared. What are we going to do with that 19x? How are we going to write 19x? Yeah, plus 21x minus 2x. And then don't forget the minus 7. Right? So now instead of using that box for that area method, I can use grouping. So when I look at my 4 terms, I got to group them somehow. So again, I'm going to look at my little 7, because look, can I pair those 2 together? No. Can I pair these 2 together? No. Right. So can I pair these 2 together? And then I'm going to pair these 2 together. Right. So just for simplicity, I'm just going to rewrite it. So we're going to pair up 6x squared minus 2x, and then we're going to pair up plus 21x minus 7. Right? If I pair up these 2 guys, what's the greatest common factor I can pull out? 2x. And what am I left with? X minus 1. Right? And then now I'm going to pair up these 2 guys. What's the greatest common factor I can pull out of those 2? Yeah, positive 7? Yep. So then I'm going to have what? 3x minus 1. Oh my goodness. Wait. How about should I have a 3 right there? Right? 2x times 3x is 6x squared. Right? So see, as soon as I make a little boo-boo, I kind of took a pause, like, wait a minute. These technically should be pair matching up, and why aren't they? Because I just, decided to write an invisible 3 today. Yep. So now I can factor out 3x minus 1, and then I still have 2x plus 7. So now I have my 2 factors. And if you wanted to do that area model with the box, you're going to get the exact same answer.